Now we are going to start with the stability studies. So why do we need to study the stability of power systems? So we know that power systems are very huge. They contain a huge number of generators, transmission systems and loads, right? Now what happens, there is bound to be some variations in voltage and frequency, okay? Now these variations, they will cause oscillations in the rotor. Okay. Now this is not desirable. This oscillations, they might result in loss of synchronism. So stability studies, it involves the maintenance of synchronism in the power systems, which is a vast interconnection of various equipments. So first we will see the definition of stability. Okay. What is a stable system? Let us say a system is operating under steady state condition. Now if in that system some disturbance is occurring, okay, that system should be able to get back to its original steady state, or it should be able to get back to a new steady state. Okay. Now what is a steady state? Right, a steady state is nothing but a operation in which the parameters are maintaining a almost constant value. They are not changing with respect to time. Okay, so that is meant by a stable system. Consider a system operating at steady state. Now after a disturbance occurs, if the system is able to eventually, that means it will take some time, it can take some time, okay, it is able to eventually reach a new or existing steady state condition within a finite time, then it is called a stable system. Now these disturbances, they can be either large disturbances or they can be small disturbances. Okay, so how they are classified into small and large disturbances. So first we will take the case of small disturbance. Here what is going to happen, the change is going to occur very gradually. Okay, so all gradual changes, they can be termed as small disturbances. Now what is the purpose of defining or classifying something into a small disturbance? It can be linearized, right? The equations that are describing this change, the mathematical equations that are describing the change, they can be linearized. So once something can be linearized, it is easier to analyze, right? Linear systems are easier to analyze. So the non-linear equations describing the change can be linearized for the purpose of analysis. Next, large disturbances. So if small disturbance is gradual change, then large disturbance is nothing but sudden changes. Okay, and here the equations, they cannot be linearized. So large disturbance is sudden changes and the non-linear equations describing the system cannot be linearized. Okay. Now the stability studies also, they are classified into different types. So we will see what are these different types. The first one is the steady state stability study. Now if you consider a system which is operating under steady state, if it is going through a small disturbance, okay, then if it is able to reach back to a steady state condition, then it is called steady state stable. Then what is this steady state stability study? Okay, so this involves determination of the limit of loading so that the small disturbance will not cause the system to go into loss of synchronism or losing its stability, stable operating condition. Okay, so you can write down here, if a system after undergoing a small disturbance returns to the steady state condition, to any steady state, right, then it is called steady state stable. Steady state stability study involves determination of upper limit of loading without losing synchronism in case of small disturbances. Okay, so one thing, if you are finding all this very confusing and very in depth, then don't worry, it is hard to understand in the first go itself. So listen for now, and when you are doing the problems and we are doing the second and third revisions, it will become more clear to you. Okay, so the next kind of stability study is the dynamic stability studies. Now here what happens, these small disturbances that occur, if they are resulting in oscillations, sometimes they may lead to natural oscillations. Okay, now if these oscillations are within a certain tolerance and they die out quickly, then the system is called dynamically stable. Okay, but if it is not the case, then it is called as dynamically unstable. So you can write down here, continually occurring small disturbances may lead to a state of natural oscillations. Now, if the oscillations are within tolerance and die out quickly, then system is said to be dynamically stable. Otherwise, it is dynamically unstable. In order to ensure the dynamic stability, the system should be properly damped. Okay, system is to be suitably damped to achieve dynamic stability. And next, finally, we have the transient state stability study. So here we are going to deal with large disturbance. Okay, so if a system is able to reach a steady state condition after undergoing a large disturbance, then it is called transient state stable. Okay, so if a system after undergoing a large disturbance settles down at a steady state condition, then it is called transient state stable. And transient state stability study involves the study of system if large disturbance occurs. Okay.